We have this robot. We have a rectangle head. We have pentagon eyes, octagon ears, hexagon nose, and semicircle mouth. So basically what we have to do is we have to take the rectangle, add on the octagon ears, and then subtract the pentagon eyes, hexagon nose, and semicircle mouth. So the rectangle is just 55 times 30. That's how you calculate the area of a rectangle. And that's 1,650 units squared. Now the octagons are the ears. So if they tell me that the radius is 6, then that means I have to do my regular octagon or regular polygon things that I'm doing. So I'm going to have this triangle that I'm copying, and there are 8 of them because it's an octagon. So I have to find the area of this triangle, then multiply it by 8 because there are 8 triangles in this octagon. So since the radius is 6, we can use the 1/2 times side times sine of the angle in between it formula for the area of a triangle because I have 2 sides and the angle in between them. So 1/2 times 6 times the sine of 45 gives me about 12.728. There are 8 of those triangles in an octagon. So I multiply that by 8. And I did this on the calculator already. I got 101.823. And then, well, there actually, if I look at this picture, there are 2 of these octagons. So I can't forget that there are 2 of the octagons. So I have to multiply this by 2. I end up with 203.647. So I have the rectangle and 2 octagons. I add those. Now everything else is not part of the figure. It's not shaded, so I have to subtract it. So now, pentagons. Well, the apothem or apothem was 4, so I'm going to do my procedure. So I divide that by 5 to get the central angle, 360 divided by 5, and then I do the apothem split, and I get 36. Now I want to find this side length and that, or this x, and then multiply by 2 to get the side length. So in order to do that, I know that the tangent of 36 equals x over 4. So then I multiply the 4 over to the other side to get x by itself. X is 2.906. Now that's half the length of the side. So the side length is 5.812. And then I'm going to find the area of a triangle. So 1/2 times base, which is 5.812, times height, which is 4. That's 11.625. And there are 5 of those triangles on the inside of a pentagon. So there are 5 of those triangles. So I'd end up with 58.123 about. I mean, I'm not rounding in the calculator. So if you multiplied this by 5, you would probably get a different answer. So I'm just keeping the entire long decimal in the calculator, then multiplying it by 5. Then, remember there are 2 pentagons since there are 2 eyes in this figure. So I have 116.247 is the amount I'm subtracting. Now let's take hexagon. Hexagon has side length 5, and there's only one of them, so I don't have to worry about that. 360 divided by 5 gets me 60. And then I have this shape. So if the side length is 5, I cut it in half with the apothem, and I get 2.5. And I actually could do 1/2 times 5 times 5 times sine of 60 to get this triangle, but I'm just showing you a different way, just to remind you of 30, 60, 90 triangles. So if this is 2.5, this is going to be 2.5 square root of 3. You can draw the similar triangle on the inside if you want. So the area of one triangle is 1/2 times base, which is 5, times height, which is 2.5 square root of 3. So you get 6.25 square root of 3, which is about 10.825. Then there are 6 of those triangles in the hexagon, so I get 64.952. That's my answer. So I'm going to subtract that as well because it's not shaded. And so I have to undo that from the rectangle that I've already calculated. Finally, the semicircle has a diameter of 16, so that means the radius is 8 pi r squared, and then it's half of a circle, so I divide it by 2, I get 32 pi. So 32 pi or 100.531 if I type that in the calculator. So I just do rectangle plus octagons minus pentagons minus hexagon minus semicircle. When I do all those in the calculator, remember I'm rounding to 3 decimal places on the screen, but I didn't round any of them in my calculator. So my answer may be slightly off from yours, but I got 1,571.971 units squared. And that should give you a head start into being able to do some composite figure problems.